So 2.1, we're going to learn about relations of functions. So a function is like an equation. We have an x value and a y value, and we're just going to determine the relation between the two. So a relation is a set of pairs of input and output values. So input is the x, it's what we plug into the x. Output is the y. And you can represent a relation in 4 different ways. So we can have ordered pairs. This is one way, where you have that x comma y. Remember, your x always comes first because x comes before y in the alphabet. Bless you. We have a mapping diagram, so you have your input and your output. These are your x values here. So these are your x, these are your y's. It's just a different way of writing it. You have a table of values, again, your input and output, your x and y's. And then you could have a graph, which is just points of your coordinate pair. So this would be like, I guess this would be 4, 3, because it's your x and your y. So 4 different ways to represent relations. All of them have to do with x and y's, your input and your output. So this is an example of our input and output. These are our x values, these are our y's. Your x value is your domain, and your y values are your range. So in problem 2, it says, what are the domain and range of the relation? So to find the domain, we write it as a set. So we do like that little squiggly line here because it's just going to be a set of numbers. And it's all of our x values for these points here. If a number repeats, you don't write it twice. So what's one x value that we have here? 0. What's another? 4. And another one? And another one? And the last one? Awesome. So that would be our domain, just the x values. Our range is the y values. So what's a y value? 10,000. What's another one? 9,744. And another one? 8,976. And another one? 7,696. Awesome. And the last one? 5,900. Perfect. So it's just all of our y values from these points. Super important. Domain is x values, range is y values. Any questions here? All right, a function is a relation in which each element of the domain is paired with exactly one element in the range. So again, we have here domain is x values, range is y values. We have 3 different types of functions, but we're not going to focus on the different types. But our 3 different types are one-to-one functions, on-to functions. So when you have like 2 numbers in your domain that point to 1, because I always think of it as like there's 2 on 1, so it's on-to function. And then one-to-one is where everything matches up perfectly. But we're just going to focus on whether something is a function or not. So it's not a function when you have at least one x value with 2 or more y values. So if I had my function represented like this, where I had the 2 boxes, if I had an x with 2 arrows coming out of it to 2 different y values, so y1 and y2, this would be not a function. So if I had 2 arrows coming out of the x, that would be not a function. If I had a coordinate pair listed, and let's say I had 3, 4, and 3, 2. If I have the same x repeated, this would be not a function. So if your x is repeating, it's not a function. So for A, state the domain and range of each relation, then determine whether each relation is a function. So let's start with our domain. Is domain our x values or y values? X values. So what are our x values here? Uh-huh. Mm-hmm. Awesome. So it's all of our x values. We have -6, -5, -3, -1, and 6. Now for our range. Range would be the y values. So what are our y values? Awesome. -1, -9, -7, 7, and -9. -9 repeats. So do I have to write it again? No. Nope. You don't have to write it if it repeats. So do we think this is a function or not? Yes. Why? Awesome. None of our x values repeat, so yes, this is a function. So even though we have a y value that repeats, all we care about is whether our x's repeat. You can have y's that repeat, you just can't have x's that repeat. So this is a function. Any questions here? Bless you. Bless you. All right, state the domain and range of each relation, then determine whether each relation is a function. So what is our domain? So we have two 2's. So right off the bat, we know that we have an x value that repeats, so it would be not a function. Our domain would just be 2, -1, and -2, because you don't repeat the numbers that are listed twice. If it's repeated, you don't list it twice. What would our range be? -2, -1, 0, 1, and 2. Awesome. And this we said was not a function because our x values repeat. Can't have your x values repeat. Any questions? All right, next it says you can use the vertical line test to determine whether the relation is a function. So the vertical line test is you just take like your pencil, any vertical line, take your pencil vertically, put it over your graph. If it touches at 2 points, it fails the vertical line test and it's not a function. So here, we would take a vertical line and it only touches the graph at 1 point at a time, anywhere you put that vertical line. This one, if we put a vertical line here, it touches at 2 points. So this fails the vertical line test, so it would be not a function. So if it touches at 2 points, it's not a function. The first one would be a function because it passes the vertical line test. Any questions here? All right, determine whether each relation is a function. So 1a, we just have points. Does this pass the vertical line test? If I put my pencil over all these points, is there anywhere where there's 2 dots touching?
No, because that's not a function because there's 2 dots that are the same.
So if I put a vertical line through here, I have 2 dots that are touching. So it fails the vertical line test, so this would be not a function. Can you see that? Nope. Not a function. All right, what about 1b? What do we think? Is it a function?
Yes.
Why?
Because there's no x values in it.
Awesome. There's no x value that has 2 arrows going out of it, so this would be a function. Any questions here? right, determine if each graph is a function. What do we think for the first one on the left? Not a function, because I could put my line anywhere through it, touches at 2 points, so it fails. Not a function. What about for the second one on the right? It's a function. So if I put a vertical line anywhere through this graph, it's only ever going to touch at 1 point. You can just take your pencil and hover over it and see if there's any point where it touches that 2. But there is none, so that would be a function. All right, last thing we're going to do is evaluating functions. So sometimes we have equations that are written as y is equal to, and our equation. Sometimes it looks like this. F of x, that's what this is called, f with the x in the parentheses, it's f of x, is the same thing as saying y. It's just a fancy way of writing y. For these problems, it's going to tell us f of some number, so like f of 2. And we would just take 2 and plug it in to the x's. So whatever is inside of that parentheses, that's what we need to plug in to our equation. So it's kind of the same thing we did in like 1.1. We just have to follow PEMDAS, but it's not saying like x is equal to this. It's just going to give it to us in that parentheses. So it tells us like this is what you have to plug into your x's. So we're given f of x is equal to 2 times x squared minus 8, and we have to find f of 6. So what am I plugging into x? 6. F of 6. So I plug that 6 into x. So I have 2 times 6 squared minus 8. So PEMDAS, what should I do first? The exponent. So what's 6 squared? PEMDAS, what should I do next? What's 2 times 36? 72. And then lastly, what's 72 minus 8? Awesome, 64. So we write our answers as a pair here. This one doesn't say it, but I think in the homework it'll say write it as a coordinate pair. So what did we plug in for x? 6. And what did we get for y? 64. So this is how we would write our answer. You start with your x, whatever you plugged in, your input, what you plug in, and this would be your y, what you get out. Any questions here? Yes. All right, last example. What do I need to plug in for x? -3. So I have -4 times -3 minus 8. PEMDAS, what should I do first? Kind of distribute, but what am I doing? Multiply what? What's -4 times -3? 12. And 12 minus 8 is 4. So how would I write my answer? Awesome. -3, 4, because this is what I plugged in for x, and that's what I got for y.